Thanks, thanks everyone for joining this session. Today is day number 10, and today we are going to learn more about SD-WAN template. What we will do that we will generate means whatever we left over in day number 9, will complete all those steps, and then that template will go and push to one device first, and later we'll try to push the same template to two devices, two DC devices. While creating this template, you know that we are creating lot of variables. So if you have variables, that means you can push to good amount of devices, because what you want to change to different devices, you want to change maybe the site ID, you want to change the host name, you want to change the VPN 0 interface IP addresses, but you are not changing so many things. So whatever things that you want to change, that make it as variable, and then you can reuse that same template at multiple places. Okay, so let's go back and complete that task that we are doing earlier. Now, since we are doing this yesterday, and we haven't saved our device configuration template. So you can see that it's not there. We have to go and create the template from zero. But good thing here is this, that whatever feature templates that we have created, it should be there. And while creating the feature template, we have given the initials for that feature template as RAT. So if I go ahead and search with RAT, you'll find that whatever feature template that will start with RAT, you can see here. Okay, and let's filter here non-default. This is non-default only. But you can see if I scroll a little bit down, total how many? 98. If I scroll a little down, you can see that we have RAT related templates, but I just wanted to search a specific. Yeah, now you can see that you have 1, 2, 3, 4, 5, 6 templates that we have created. These are the feature templates, part of device template. So let's go back and check the device template. You can see that device template is not here. Why it is not here? Because we haven't created that. We haven't clicked to create button. So that's why it is not showing here. No problem. We'll go and create new device template. And good thing about this, that whatever feature template that we have created yesterday, it will pop up automatically. We'll go and fill those places. This is for VeloCloud. SD-WAN Edge, and DC generic template. I should use underscore because it will not take the spaces. Okay, now you can see that we are creating new device template, and creating these device template, you can see that we will get this option to fill that features. So here I have this RAT system DC. Then I can go and use that login, NTP archive, leave it at the moment. Then we have AAA, we have OMP, we have BFD. We are using this factory default for security at the moment. Leave it as it is. Then we have a VPN 0. Then we want to create template for VPN interfaces. But before doing that, I just wanted to log into any of the device, that DC device, just to get the information about what exactly we have present in the interface. Let me go increase the font size. Balance. Even the color as well. Mm, okay. Okay, no problem. So I from here from this vManage, I'll go and log in to one of the edge device, one of the DC edge device. So we can SSH 10.1, maybe 0.1 is the system IP, DC1 VS1. Show run VPN 0 and interface. It may have two interface. Let's see what interface it has. Gig E0/1 and 0/2. So here you can see that over the interface, the configuration that we have, in that configuration, you can see that we have QoS as well, right? Later on, you will understand that QoS will fall under localized policy. At the moment, I'll not configure this QoS, but in future, when we learn policies, then I'll go and configure it. So don't worry about that. Apart from this QoS, we are going to configure everything on this particular interface. So what you need IP address. This IP address you can make as a variable. Tunnel interface encapsulation IPsec. This is MPLS restrict. Now, what does it mean by restrict? You know, what's the use of this restrict? If we are using color as a restrict, what's the use of that? See, I told you earlier that if you have branch, suppose I have one of the branch, I have two devices there. This branch have ID, site ID 10, and then maybe somewhere, some other location, you have other branch whose site ID is 20. Now, if we have different site IDs, then they will go and form the IPsec connection, right? That we have discussed earlier. Now, suppose if you have two different transport, suppose you have MPLS and internet, and what you want? You want that MPLS over MPLS transport, the other device um, will go and form the IPsec tunnel only over MPLS. The internet, the other device will go and form the internet tunnel only over internet ISP or internet carrier. So if you go and use restrict keyword, what will happen? MPLS will go and form the IPsec tunnel only with MPLS. Internet will go and form only with internet. Otherwise, by default, what's the default nature? Default nature is this, that MPLS will try to form IPsec with internet, MPLS with MPLS, internet with MPLS, internet with internet. But if you go and use this restrict keyword over the color, then it will restrict to same color, MPLS to MPLS, internet to internet. Okay?
Ratnesh,
Yep.
so what is the best practice normally in the production people follow?
That's really hard question. As per Cisco SD-WAN, we should not use restrict because we want all transport to form IPsec connectivity. But there may be some use cases that people want to use restrict for certain connections, certain traffic. So Cisco is giving flexibility, use anything. Suppose if you have high sensitive data, You don't want to send over internet circuit. You want to use dedicated line. So you can use restrict, right?
Okay.
It depends upon use case. Okay, all right. So let's go and try to create one template for Gigi01, and let's check this. But what I want to use here, let me check. 02 is there. Yep, 02 is there. I just wanted to create two interface here. See here we have two interfaces under VPN 0. I want to create a template for both the interfaces. You will see that there is some minor change that we need to do. There is not much we have to do. Minor changes and it will work. So let's create two interface. You can see at the moment you can see only one, right? VPN interface, but you can go here and click VPN interface, and you can see that now you have two interfaces that you can go and create. So let's start with first one, create the template. It will pop up where you can go and give the name and all those things. So I can go and give the name, say DC VPN 0 iNet internet. This I want to create for internet, and then again I'll create one for MPLS. Now over the interface you can go and give the tunnel, NAT configuration, VRRP configuration. If it is a service side VPN, you want to create redundancy in terms of gateway. You can go and do the ACL and QoS configuration, that is part of localized policy, some sort of ARC configuration, ARP configuration. You have this 8021X configuration if you want to provide some security related to integration with ICE and all. Then some advanced feature is there. Okay, let's see all these one by one. Shutdown, no. So if you go and click shutdown, means by default these interfaces are shut down. I don't want to do this. I want to make shutdown no. That means this is no shutdown. This is up interface. Interface name. Now interface name, it's up to us. We want to create this as a template. So again, it depends upon design use case. Why? Because there may be chances that few of the organizations, what they're doing, that all the time they are connecting their gig 0. So there are chances that they want to connect gig 0/1 always with internet, and then gig 0+2 always with MPLS. There may be chance that they have such type of design. Now, if you don't have such type of design, maybe in one place you are connecting the interface going towards internet with gig 01. Another place maybe you have gig 03, gig 04, etc., etc. So in that case, you can make this as a variable. But suppose you know that everywhere I have to connect gig 01 or 2 as an internet MPLS, so then you can make as a global. Okay. So it depends. The moment I will go and check that what interface we have here, I know that that is gig 0/2. I want to fix this as a global for my internet. Description like is interface description. You can go and give that let me go and give that. This, oops. This is internet facing interface, whatever. Any interface, any description you can give. All right. Then Let me scroll slowly so you can see everything. So I'm scrolling here. Now you want to put IP via DHCP, so that's why you have this dynamic option, or you want to assign this IP manually. Let me see that what IP we have. Do we have? Yeah, so you can see that we have manual IP configuration here, but this IP may change different places. So this IP before address, I'll make this as a variable, and we can put the nodes here. This is my DC, internet interface. Like that, you can give the variable name. You have secondary IP, you can go and put maximum up to 4 IP addresses. No, we don't have. Great. So we are very much okay here. I can scroll a little bit down. We have option here to give upstream and downstream bandwidth. It's very much similar like what we have in Meraki. Okay. Then is this interface tunnel interface? The answer is yes. This is our tunnel interface because over this interface, I may have my DTLS connection. Over this interface, I may have my IPsec connection. Over this interface, I may have OMP connections inside the DTLS or TLS, right? So yes, this is tunnel interface. So what you need to do, you need to click here. At the moment I'll go and click here, you'll see that some other options will come automatically. So if I go and click here on, you'll see that other options are coming. Do you have per tunnel QS? Means tunnel based QS. You can go and give tunnel based QS. It is actually, I think, new feature added inside SD-WAN. Initially it was there in IWAN. When you're running DM VPN tunnels in phase 3, there you can go and give the QS related configuration over the tunnels, all the tunnels. So here also you can go and give that. The moment leave it, we'll check this later on in the QS section. Then color. Yes, we have a specific color. And what's the color we have? We want to choose here on this interface, internet. So you can see that this color I want to use. There you have restrict on or off. At the moment I will make this off, but we have option, we can make this on or off up to us. This is part of any group. No, we are not using any group at the moment. Leave that group. Then border. This border concept, you know how it came? Um, Cisco is offering some sort of integration in between LAN and WAN. That term is that you have your DNA. Inside DNA, you want to enable SDA, software defined network, or software defined access. Now, if you have your WAN and your LAN router, obviously there will be some boundary. So that boundary router is termed as a border router. In this border router, from LAN perspective, you'll find that we have to enable Lisp in the LAN side. SDA, they are understanding Lisp. That's their control plane protocol. In WAN side, what you have? In WAN side, you have something called OMP, right? So if you have that type of integration, you want to exchange the routes in between Lisp to OMP, OMP to Lisp. So in that case, you have to enable this as on. Yeah. Otherwise, it's off in this particular section. Leave it. maximum control connection. Again, you can go and check per interface how many maximum control connection it can handle. It may be 16 or 32. Let's see, give some higher number. It's 8 only. It's multiple of 2. Leave it as default. I'll go and make this as a default. Then exclude the controller group list. Whenever we are talking about controllers anywhere, you'll find that controllers means VSmart. Now we have discussed this concept long back, that if you have a group of VSmart, so let me try to draw here. Suppose if I have two group, inside that group you have multiple VSmarts. Now in these groups, suppose this is group ID 10, this is group ID 20. Now you have one edge device who want to part of group number 10, who don't want to part of group number 20, then you can go and use exclude controller group 20. So that means it will not form the control connection with group 20 VSmarts. Okay. And then we manage connection preference. It's 5. The range is 1 to 8. So suppose this particular device can reach to be managed via two transport, MPLS and internet. If you put 5 here and if you put 6 here, so it will go and form the control connection with vmanage via internet circuit. Okay, because this is 6. This is something like weighted preference option. This option also we have checked earlier. Then low bandwidth link is off, you know that.
Ratnesh?
Mm-hmm.
Yeah, sorry to interrupt you.
Yeah, yeah.
Could you please go back in the grouping?
Let me scroll up.
No, grouping, the diagram you created here.
Diagram, I just deleted that diagram.
Okay.
Group of VSmart, you're telling?
Yes.
Okay, let me redraw that. Okay, so suppose if you have two groups and you have VSmarts inside that group. Okay,
Mhm.
what is your question? And then you
My
have your.
question is here, suppose that in the branch side, there is suppose that two different branches at customer premises, and one branch is going to connect with the site ID 10 vSmart, and this is the primary vSmart for the branch number one, and the secondary branch is going to create a backup circuit on this 20. Or you can say that the another branch is going for the backup for this 10 site ID, and similarly, like vice versa, you can create for the branch one and branch two. It's just like as the standby and the primary.
Yes, we can make it primary and standby, secondary. Yes. What is your question? Hello. I think I lose Sanjay. You're there?
I can hear you.
Yeah, Sanjay. What is your question here?
Yeah, sorry, actually my internet is disconnected. Okay.
Mm-hmm.
Yeah, okay. So there is a two branch site, okay, and it is the full mesh technology here, okay. So you can create another branch here. There is a one branch you are going to connect primary and secondary, another branch one here.
Mm-hmm.
Yeah. So suppose that this green color box is the branch one, and this red color box is the branch two, and this
Mm-hmm.
yeah, branch one and branch
Okay.
two.
Okay. Continue.
Yeah. So my question is here, this branch 2 is connecting to the primary B smart, that is the site ID 20 at the hub site, okay? Or maybe you can say it anywhere in the clouds it is working for the primary. And this branch number 1 is going to connect to the this site ID 10. Okay, and once this is site ID 10 will be failure, it will be automatically switch over to the this branch number 2. Means it is just like as a backup we are going to create at the vSmart. Got it my point?
So if primary will fail, obviously this will become primary.
Yeah, so how this scenario we can create in this template? When suppose that if branch number 1 is going to communicate to the site ID 10, that is the for primary. So once the this site ID will be active, 10 will be active, the data will be whatever the service side data will be going to advertise towards the OMP, it will reach to the site number 10. And once the site number 10 vSmart will be below, it will be automatically switch over to the site ID 10 20 vSmart. So how we can create this scenario in the this template?
I I think I told you earlier that we have lab related to this. When we go study about high availability redundancy, then
Uh-huh.
I'll cover this.
Okay, okay. Later it will come, right?
Yeah, it will come later. Yeah, because not only this particular list that we are seeing here, but suppose if you have VS Smart, first of all, those VS Smart you have to put inside some group. At the moment, we are not creating group for VS Smart in our lab so far. We'll do it later. So
Okay.
once your VS Smart is part of group, then your VS devices, you'll see the configuration how we are doing. So for one of VH, it will be primary, it will be secondary, and for other VH in some other branch, it will be primary, it will be secondary. The
Correct.
configuration is very easy. You will see later on.
Yeah, I think we can create the centralized data policy, right? The centralized control policy.
Mm. Let's see.
Yeah, you can explain me later.
We'll see later. No
Yeah, yeah,
problem.
sure.
Ratnesh, I have one question here.
Mhm.
So this B smart in the group you told last time, right? It is all individual IP, right? Not any like one virtual IP, all an individual IP, right? Inside the
VS
group.
Smart or individual IPs, yes.
So for the BAG, it has to know all the individual IPs, huh? For B smart.
Yes.
Okay, okay,
Right.
continue.
Okay, great questions. Okay, let's continue and clear the drawing. Great. So like that, then over the interfaces, so if you go to the interface, you'll find that we are allowing or disallowing certain services. So allow BGP or no allow BGP, it's up to us. So here in the list also you can see that we can allow or disallow different services over this particular interface. The moment I'm leaving this as default, then you have this advanced option. Let's see what is there in this advanced option. Oops. Let me scroll a little bit down. Up. Now in the advanced option, you can see that is this particular interface. Let me scroll a little bit more up so you can see everything. Starting with encapsulation, is it GRE or IPsec? Yes, this is encapsulation IPsec. Then IPsec preference. What does it mean by IPsec preference? You will understand in upcoming section in OMP and TLOG. From IPsec preference also or TLOG preference also, we can choose path A versus path B. So, in BGP, we have certain path selection criteria, maybe 13 or 14 different parameters. It's checking 1, 2, 3, 4, 5, 6. Like that, here also you'll find that OMP having same type of path selection or best path selection criteria. And in that criteria, although the list is little bit small than BGP, but in that you'll find that TLOC preference will fall under maybe 6th or 7th number. You'll find this. Likewise, you have IPsec weight. It's very much similar to local preference weight, that we have in BGP. We'll discuss this later on. Then you have the carrier, then you have the bind loopback tunnel. In case you want to extend the control plane, you can use this loopback tunnel option. You can see bind the loopback tunnel interfaces to a physical interface. Then you have this last resort circuit, you have hold down timer. Few things are default, NAT refresh, hello interval. This I'm going to cover, and this particular section I will cover in BFT. Hello interval at least. Tolerance also will come into that notes, but three things are there: hello interval, dead interval, tolerance. Okay, and then some other features. Let's see. So long list here. You can see this long list. If you are enabling NAT, if you are doing VRRP, obviously we have lab related to VRRP, so you'll understand about that. Concept wise, we know that what is VRRP or HSRP. Here we are using VRRP. At the moment it is disabled. Whenever you have service side VPN, there you can go and configure it. I will touch this VRRP, don't worry. Then we have ACL and QS also. It will come in localized policy, so do not worry about this. You will understand each and everything. We have nice QS template, QS slide. All right. Then what other thing? ARP. You know that what is ARP 802.1x. You know that also. Then we have the advanced option like duplex, MAC, IPMTU, path MTU, discovery, flow controls, MSS, speed, don't fragment. But these are some of the advanced option. When we are getting some trouble in network, then we'll go and check these things. By default, okay, it's okay at the moment that few of the items are default. Few of the items you can go and change as well as per the requirement. T-lock extension, we have lab for that in future. So don't worry about this section as well. What is T-lock extension? It is a way to extend the control plane. I will check that. All right. So you can see that these many options we have, but what we have done, we have enabled very few options. What we have done, let's quickly see. So we have made that interface as a no shutdown using this option, shutdown no. Then we have defined here that what's the interface name, interface description. We are going to put a static IP, but this IP is variable. We are going to put it manually when we push the template. Tunnel is on and the color is internet. The restrict keyword is off. Okay, and rest of the templates are very much default. I can click save here. So now we have created one of the interface inside VPN 0, and that is related to internet. I will go and create one more. Okay, and that will be related to internet. Sorry, that will be related to MPLS. This is internet. Now I'm going to show you one trick here, but for that I have to come out from this. Okay, so I'll do one thing. I will delete this. I'll click create. Again, we'll go and edit that. So don't worry about that. I'm not going to push this template at the moment. This name of template is RADDC generic template, etc. That's the name. But still we have to go and add interfaces, VPN 512, etc., etc. We are going to do that. no problem. But I want to create one more more template inside VPN 0. So what you can do, you can go back to feature template. You search your VPN 0 interface, that is for internet. In the bottom, you can see that we have created this global. Now what I will do, just to save our time, what we can do, we can go click here, these three dots are there. You have this option called copy. Click to copy, and you just change the name. Instead of INET, this is for MPLS. Description also I'll go and change MPLS. Click copy. And now you can see that you have this MPLS, but parameters are same. So you can go and click edit. And once you go and click edit, that particular template will come. And we'll go and change few of the things. So the interface that we have for MPLS is Gigi 0/1. This is MPLS facing interface. Okay. Static IP, but I want to change the variable name as well. So what I want here, MPLS. Okay. And we'll go and change the tunnel. So this is not the biz internet, but this is MPLS. I'll go and search MPLS. You'll see somewhere MPLS. The rest of the things are same, right? So we can go and click update.
So in production environment, we are always using this global configuration, right?
Global.
When you are going to configure the interface, there is the option for the default device specific and the global.
Where?
Yeah, when you are going to create a template, in that I saw that you are always selecting the global. Any you can open it. You can just create a one add template and you can show me.
Okay, I understood what you are telling here, that this resource group is global. Means, I don't know. We are using this global only while creating, but let me see if any changes are there. So if I click add template, right, where we are getting this option you are telling, I'll go and search cloud. Okay, like that you are telling. Okay, leave it at the moment. We'll check. I have to complete this template. I'll come back to that. At the moment, everything is falling under global. Resource group is global. Okay. All right.
Okay.
So where we reached at this point we reach up to VPN 0 and 2 interfaces. Apart from that, we have VPN 512, right? And interface inside VPN 512. Remember, in the previous section, I told you that you have two ways that you can go and create your template. One way that you go and start creating template inside device template. So what we have done, we created device template, and inside that we are creating a small template. The other way you have is this, that you can go and create the feature templates and then put everything inside the big device template, right? So what I'm going to do now is that the rest of the template I will go and create inside feature template, and then I will call inside big template. Okay, so we can see some differences as well. So if you have to create feature template, what you can do here, click here on top, first of all, feature template, click to add template, search the hardware you want to create that. In our case is VeloCloud, and then here you can see that it is telling you option to create those feature templates. We have already created this system wide. We have created this VPN template, but we have created a VPN template for service and manage. We haven't created management. We have created just for VPN 0. I need to go and create template for VPN 512 as well. And let's go here. So I have to create VPN 512, and inside that VPN 512, I have to go and create a template for one of the interface. Okay, so what we are going to do now is that we'll go and create template for VPN 512. That will be our management interface. Inside that we have to create one interface as well, interface for VPN 512. So these two templates we are going to create. Oops, 512. All right, let's do this. So we are inside VPN section. You can see that you can go and use this to create the VPN. And then here you can see VPN interface Ethernet. Management is there, WAN is there, LAN is there. We are concerned about this management interface. That means we'll go and use these two options. So first of all, go and create the interface inside this VPN. Slowly it is loading, but no problem, let him load. Meanwhile, we'll go and check the configuration for VPN. Oops, it's down. VPN 512. Sure, and VPN 512. What is there? Interface is ETH0. Most of the time, maybe 95% time, you have interface ETH0. IP address, no shutdown. That's it. And then the static route, IP route. So these are the configuration that we want to give here. So let's do it. Template name, TCN VPN 512. All right. Although you can see that it is exact that we have created for VPN 0. All options are there, but you don't need all those options because this is just a management interface. You give the VPN name, then you can go and give the IP address. Means IP address means IPv4 uh, IP route, a static route like this. You'll get that option. Now this portion that you are seeing here in bottom, these three lines, this will come under VPN 512 interface template. At the moment, we have to give only these two lines, VPN 512 and this IP route. That's it. So let's just scroll down. Scroll down where I can go and add the IPv4 route. So here we have the new IPv4 route, and this is 0000/0, and then we can go and add one next hop interface here. Add one next hop interface. That next hop interface I want to create as a variable. I want to use my own variable name. This is for MGMT. Next hop. Management interface next hop, right? click add here. So we are very much done with our VPN 512 template. Then we have to go and create one more for VPN 512 interface. So click add template, search that hardware or the S device. Scroll a little bit down here, check where is your VPN interface. Here you have. It's coming. I can go and give the I can go and give the name. This is RATC VPN 512 interface. Okay, and shut down. No. Name of interface, we know that is ETH0. We'll confirm here. ETH0, that's right. Scroll down. Description, I'll leave it at the moment. Or if you want, you can give, no problem. Interface. Then IP is a static, and that IP we want to define here. MZMT interface IP address. And I think that's it. You don't need to enable tunnel and color and all those things because this is management interface. Click yes. Now we have almost all templates, basic templates for our device template. So again, I can go to this particular device template. I can go click this 3 dots here, click edit, and we can go back to the transport and management VPN, where we can go and add one more VPN interface. In this VPN interface, we can go and call that particular template that we have created, TC VPN 0 MPLS. Then we can go inside VPN 512. Then we can add interface for VPN 512. We can go and let me scroll a little bit down. We can go and add the VPN 512 interface template. Okay, and then service VPN, you can check later on. They're not creating. Then you can go and create the banner. It's very easy to create it. Policy will check later on. SNMP configuration, you can go and do it. Security policy, we can check later on. Okay.
Yeah, Ratnesh, here I just decide that you are going to create a static default route, right? In which you are putting the next hop is the 192 series IP.
Yep.
So, what is the purpose of that one, the static IP?
Static IP means
Yes, yes. This is static IP. IP route. This is a default route you are adding, right? 192.18.3.1.
yes, this is our
Yeah.
management subnet. So we are pointing our management subnet. This is the gateway for the management IP. So we have
Hello.
Yes, Sanjay. You're able to hear me?
Yeah.
Hello, Sanjay, you're there?
Ratnesh, where is this 3.1 gateway?
This is our management IP gateway. This is
Means
out of band management IP.
uh, mm, is gateway located where? This
This gateway is located inside. This is part of VM only. So this is one of the subnet block for management. This is management gateway. Inside that, we are assigning IPs like 3.100, 3.101. Suppose if I want to access this particular device from outside, so if I go here and open my putty and 198.183.100, see from outside
Mm-hmm.
I have logged into this device. Likewise, if I go and 198.181.101, no, sorry, 3.101, right? Sanjay, you're back? 98183.101. So you will see that we are inside other device, that is VH2, VH1, VH2. This is just UB
Mm-hmm.
IP. Gateway is pointing towards management IP.
Okay.
Okay, all right, let's continue and let's try to push this particular template that we have created to one of the device. So now I can go and click update to this particular template. And you can see that we have this template, but this is not attached to any of the devices. And if you go and check these specifics about this particular template, you'll find that this is a feature template for VeloCloud having 11 different feature templates. It is not attached to any of the device, it is in sync. So now let's try to attach this particular template to one of the data center device. We have option here to click attach the device, attach devices. You can go and select, click TC1, VZ1, click attach. Now once you are clicking here attach, now you can see that okay, it will attach, but it is missing certain parameters. It is missing some sort of IPv4 management address. So many things it is missing. You can click here, you can put those values, or you can click to this three dot, click edit device template. It will tell you in detail what are the things it is missing. So here you can see that IPv4 management address. What is that IPv4 management address? Let's see. This is this. All right. Then address MPLS gateway, internet gateway. These are the static routes, right? It's auto-populated, but you can see these are the variables. DC MPLS interface. We have created this DC MPLS interface. If you go and check for MPLS, you have IP 164.0.2. For MPLS, you have IP 164.0.2. For internet, you have IP 164.2.26. Internet, that's right. Host name is right. Then these things also you can change, latitude and longitude. Then system IP, site ID. So whatever things that we have created as a variable, you can see here. This we have created as variable. This we have created as a variable. It is populating here. This VPN 512 gateway populating here all variables. What I need to do here, I need to click update. So now it has fulfilled all these parameters. This is one of the way that you can assign the variable. There is other way as well. Other way is this, that at this point of time, when you haven't uploaded the variables, you download this CSV file. Download button is there, right? You can download the CSV file. Once you have this particular CSV file, I think it will not open here, but okay, you can see, right? So this CSV file, you can see this is just the CSV file. You'll find that there is no variable in this CSV file. Whatever place that we haven't put that variable. So what you do, you download that empty file without variable, put those IP addresses, host name, latitude, longitude, etc. Then once you do that uh, fulfillment, you can go back here and then you have option to upload that. So click this upload button, choose that file, table location, you have your CSV file, upload it. See, is in progress. Click upload. So it will go and put all those variables in correct places, right? So either way you want to do it, you have to you have to assign all those variables here. Great, we can go and click next. If you want to see the previous configuration and the existing configuration, then you can select this device. It is generating the configuration preview. So this is the configuration we want to put, but if you want to see the difference, and if you want to see the side-by-side difference, so you can see that new configuration, it is missing all these parameters that is highlighted here. In new configuration, we haven't put any SNMP configuration, so it is not there. We have done some changes related to path limit or ECMP limit, so it will show you there. We have put some sort of description. It was not there in the old configuration, so you can see that. Whatever changes are there, we haven't do any configuration related to QoS, service firewall, etc. So those things are there, right? QoS configuration, you can see it is not there in the new template. No problem. Click config the device. It is in progress now. It is doing this validation config check. If everything is okay, then it will try to push this configuration to this particular device. Okay, and you will get the success message. It is successful now, seems. Okay, and let's go back here and see. So you can see now we have successfully pushed that particular template, and you can see all these descriptions are there that we have put. And other thing you can see that now we don't have any service VPNs, right? We don't have VPN 10, 20, 30 that was there earlier. Now you can go back to the configuration and template. You can go to the device template. And now you can see that RAT DC generic template is pushed to one of the device, and that device is what? A DC1BH1. Now the point here is this, that is this template I can go and push to other devices as well. Now, it depends on how much variables we have in this particular template. If we have created enough variables, then why not? So let's try to push the same template to DC1 VH2. Again, go click the three dots, click attach devices. And now I want to push this template to this particular DC as well. I can see that it is requiring some variables. Let's see. Okay, so it don't have management interface IP address. Gateway is, I think, both are same in both the places. Let's go back here. Let's exit from this. Let's try to log into the other device. See what are the parameters we are missing. Sure and VPN 512. This is the management IP 101/24. The rest of the parameters are also variables, auto-populated, but if it is not there, you have to go and assign the correct IPs. Suppose you want to change the host name, I'll go and make this as a new. So I understand that it is going to push this particular template. Yes, so the things are 100% okay. I can click update. And we can go to next. We can go to configure devices. Now we can see that validation is in progress. It is successful. We are inside this particular device. You will see the host name will get changed because we are using new template, right? And show interface description. Now we have our
This next hop IP, that is the 192.18.3.1 that you are putting in the static route, where it is located.
this is actually this lab is also set up on VM. So this particular VM having one management subnet like we have, in our lab also we have one management interface part of VPN 512, right? So this
Okay.
3.1 gateway is belonging to my VM system. It's just the gateway. Even if I do not give that gateway, still we are able to access this particular system. This is our gateway IP, that is VM itself.
Means how it is going to communicate, that I exactly wanted to understand. Means suppose that you are creating in the virtual machine and it is reaching to the next hop, that is the 192.18.31.1, right? Whatever the next hop IP. And it is mentioned that the default route is going through this gateway. And this default route is maybe somewhere in the internet, right?
Okay. This default route is natted with internet, yes.
Yes, yes, yes. So where this IP exactly means it is located in somewhere in the firewall where it is going to pass that security option or filtering that gateway and passing that traffic that is coming from this VS2 or VS1 and they provide the internet connectivity to come to the communicate with the we want to
Okay.
come into the SD-WAN fabric.
Okay. So I'll answer that.
Yeah,
You have one interface called VPN 0, right?
correct.
So your VPN 0 interface that you have, this is going connecting to VSmart and other controllers.
Mhm.
But then you have something called service side VPN as well. And you have management VPN as well. This management VPN having subnet 3.0, you don't have to do anything with this these IPs that they are going towards the ISP. This is one part of management IP, all the boxes they have one management interface going towards one management switch where you are doing out of band management, OOB. And this particular whatever subnets that is going towards anywhere, it may be firewall, it may be global router switch, etc. In that particular switch or router or firewall, you are doing NAT, and with that particular NAT, other devices can access to these boxes in the back. This is some sort of backdoor connection to these devices.
So you are saying that there is the VPN 512, that is a separate
Management
segmentation
VRF, yeah.
traffic. Yeah, management VPN, yeah, understood. That is going to connect to the somewhere in any device, and from that device we are going to manage this
Yes.
outer band, right?
Yes, some NAT is there, some other things are there, some routing is there, and from there we are accessing these devices as a backdoor. Yes.
So usually, what we are using in the production network means we are going to connect the one with wireless outer band devices and going to connect to the many console port, because the console port is going to provide our management, you can say management and console both. So practically, I'm saying you. So that is the wireless OB devices that is going to connect to this Cisco VS devices, and there is the management port and the control port is there, and they are going to connect directly on that port, and we have the IP of that outer band devices, and we are going to log in into the outer band, and from that outer band, we are going to taking the console access of this BitTela devices. So what exactly you were saying here means somewhere there is a server, this management server that is going to connect to this outer band,
Yes.
but that is suppose that in case of the wireless, how it is going to connect means each and every traffic is going towards the internet, right? In the wireless means we are going to connect to the one SIM card, and that is providing the one connectivity to the this management server. Is it like that?
Where is your wireless device? Is your Viptela devices are wireless as well?
No, 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 no. Actually, there is the port, means one is the management port and one is the control port, right?
Hmm.
So this port is going to connect to the out of band modem, that is a separate external devices, right?
Yes.
That out of band modem is that is the wireless. There is no physical
Means,
connectivity.
see what I'm telling that in your infra you may have some management, you may have purchased some management boxes, right? You may
Right,
have
right.
separate management, how you're doing the management. In our case, it's just one of the VRF.
Mhm.
From that VRF, we can go and access these devices. This is not exactly that what we have in your production. This is just one other segment who don't, who means that information that we as smart don't need. So whatever IP that we are putting in VRF, that is obviously non-routable. No one wants that. Just to log into this device or go out from this device. In this particular lab, it is like this.
Okay. So this 512 VPN traffic is going to connect to the any management server, right?
Yes, any management server, and that server having some NAT configuration to outside.
Outside, and that is providing the remote access to these devices, right?
Yeah, so from outside we can go and access the devices. Yeah, right.
Okay.
See, if you check this lab, if you check the what is IP config, let's see that what IP it has. See, the this has range out of band. See, this is VM oriented lab actually. So out of band access is 3.99. This is also maybe pointing towards 3.1. Some VMware IP is there. So everything, all these 3.x subnet is segmented actually from VMware. Since I have VMware access, so I can access from outside as well. Because VMware by default it is doing NAT. Remember, whenever we have created our own lab inside VMware, we haven't done any NAT. By default NAT is there. So when we have our lab here, in that lab also maybe you have seen that uh, we have assigned one interface for VPN 512, right? Two interfaces we have used here in our lab. One is for VPN 0, one is for VPN 512, and we can log into that. This is inside VMware, but it's still from my laptop I can log into that device. Okay,
Okay.
so I
This is
have,
providing the somewhere in the VMware, right?
yeah, it's inside VMware. Yes, this lab is inside VMware. Yeah, yeah, right. Yeah, this lab that we are doing practice, it is inside VMware. VMs are
Okay.
there. Yeah.
And from the this virtual machine, it is going outside of the network, right?
Yes, it's going outside of the network. By default, it will go outside. So if I log into any of the device in our lab also, you can ping to Google, you can ping 8888 DNS. Why? Because this VM that I have in my laptop, it is actually bridging with my wireless network that I have in my laptop, and then
Mhm.
traffic is going out and in.
Netting is coming here.
Yeah, by default NAT is there. Yes, you're right. Some firewall, some rule, something is there, so it can go outside, come back. Great. Let's continue where we are at the moment. Where is my remote session? Okay, here it is. Just a second. If my vManage is come back on 10, 10, 10, 34. See, this lab is working fine. Admin. And I have taken the snapshot as well for this particular lab. Anytime I can go and start from that particular place. So we have the S devices, we have the control and data plan, everything is there. No, it is not coming up at the moment. Let me quickly check. Oh, maybe some VPN issue. Oops. Interface description. 10, 10, 10. See here also in our lab. In our lab also you can see that we have management IP and VPN IP. Okay, so what we have done that we have created template, and with that template we have attached that template to two of the devices. But still you have to learn a lot more about configuration. You have to learn a lot more about templates and feature templates. I'm going to share this lab with everyone after this class. You please go create feature templates. Whenever you create feature template, do not mix with mine. You start with your first 3 4 characters or your name underscore templates. Initially, if you have any difficulty creating templates, just click 3 dots. The copy option is there. Copy that template, edit, do a small changes in that template. Then once you have all those templates, right? Once you have all 11 12 templates, that whatever we have created, then those templates you call inside device template. Okay, that particular device template you have to go and attach with PC devices. Okay, so you should see your name and then template and this attachment with two devices. This is your task that you have to complete. Okay, this
We can
lab,
use the same IP address and everything, only the device host ID will be changed, right?
yeah, only the template name you change.
Template
Rest,
name.
yeah, rest everything will be the same. So everyone can create their own templates, no problem. I want to see more templates here. You can use the same lab, no problem. Later on, we'll see there are some tricks that we can build or scrap all this configuration from the vManage. Some automation scripts are there. I'll show you how we can do it. All right, so this is about template. Let's move on. We have still 30 minutes left, so we can discuss more about some of the theoretical aspects. Now you will understand about this template, future template. But again, if you do the lab, if you do hands-on from your side, you will understand more. Okay, basic templates, transport, service VPN templates, etc. Now let's check a little bit of theory and try to understand that. So define all the device configuration parameters, enforce the configuration consistency, compliance check, high degree of, means why we are using templates. The one word answer is standardization. You want to standardize your configuration throughout your fabric, throughout all the devices. So that's why we are using template based configuration. Good. That's one answer. Then three options are there, right? Default setting, global setting, device specific configuration. Device specific means you are creating variable. What features we have seen? There are so many: security related, transport related, service related, routing like OMP, OSPF, etc., etc. Those templates you can go and create. CLI is like this. Feature template means you have big template, inside that you have so many templates you can create. Right? Great. Now this is one of the important slide, and here you can see that vManage is using netconf to configure either vSmart or edge devices. Even itself also it is using netconf to do the configuration. So netconf is the protocol we have to do the configuration from vManage itself to all the devices. Okay, these slides taken from Cisco directly, so there is no problem in these slides. They are 100% right. Then you can see some use cases as well. So you are pushing the configuration. So vManage is pushing the configuration to devices. Then what will happen? That particular device where you have pushed the configuration, that will become vManage mode, right? So if I go to devices now, so from configuration you can go to devices. Once you are inside the devices, you can see where is our DC. Say DC1 and DC1 VS2. They are in the mode of vManage. vManage. This is their template name. So they are part of vManage mode. That means you can't do any local change. Local changes are allowed only if you tear down that vManage mode. Means if it is in CLI mode, then you can go and do the local changes. Okay, if it is in vManage mode, you can't do it.
Yeah, so there is the option to convert from the vManage to CLI in case of the details troubleshooting, right?
Yeah, means you can detach that. You can see that you can go and
Yeah,
detach that template.
can you show it please? How to change it from the vManage to CLI mode?
Simply go and detach here. So you can go configuration and template. Device template. And here option detach the device. I'll detach only one at the moment. Yes, schedule. It will take 1 minute. I'll show that.
There is no configuration impact will be happen, right? Once we are going to detach it.
Yeah. So it has that last configuration, but whatever we have pushed, it will be there. Give him some time to detach it.
Because
Once,
sometimes if you want to going to bounce the port, it is not allow into the CLI mode. Means we can just working on the show command, but it is not going. Means when we are going to commit and quit, it is not taking the saving the configuration.
yeah, you're right.
Only
Yeah.
the show command, only show command is working in the vManage mode.
Yes. See, the mode is CLI now.
Yes. You only need to detach and again, if you want to change into the vManage mode, again we can push it to the
Attach the attach the
attach.
term. Yeah. So
Yeah,
now you
yeah.
can go to this device. You can run any command. But once you attach the template, whatever configuration there in the template, it will come back.
Mhm. But I think if precaution purpose, we need to write down save the template name.
Yeah, so if you want to do any change, do not do changes in your existing template. Create one copy, do changes in that copy, test with that particular copy. If it is working fine, then okay. Otherwise, otherwise it will be a big mess.
Right, right, right. So just for the precaution purpose, before going to detach or attach, we
Yeah.
need to save the template name.
Yes, yes, yeah. Means be
Yes.
careful while playing around with any configuration.
Yeah.
Anyways, we know that in operations, um, it's not that easy job operations.
Yes, yes. Operation means fully operation.
Yeah, it's not easy.
Yeah.
Whatever wrong thing that design team and the implementation team they will do, operation has to pay for that. Okay, there are some slides related to basic design. These are the easy ones we can discuss here. You can see here that while designing the template, so I told you that whenever you're designing the template, you want to make it as generic as possible. So what you need to do, you have to identify your branches. Like maybe one branch, there is one router connected with two ISP. Now this type of branch, you may have 100 branches like this. Then you may have one device connected with two internet. You may have 50 branches like this. Then chances that you have different devices with different ISP. You may have 20 branches like this. So while creating the template, how many templates you are creating? Only three, right? One for this type, one for this type, and one for this type. But how many branches actually you have? You have 170 branches. So 170 branches you are managing just with three templates, right? But for that you have to do it, do the planning properly. You have to identify your branches, what type of branches we have. Okay, so that's the power you have with the template.
So
Re,
that's
yep,
so when you say three template means three device template, right?
three device templates. Yes.
Yeah.
Yep. All right. So identify your branches. That's important, and according to that, you can go and play around. And let's check few of the slides related to design. Uh, Again, you have to argue that what type of high availability I need in my branch. Do I need two devices with two different ISPs or two devices with three different ISPs? Or I can go with some sort of T-lock extension. I haven't discussed about this T-lock extension, but there are chances that you have only one ISP and you can do some back-to-back connection with the devices with some internal IP, and then you can extend MPLS towards this device, internet towards this device. This is something called T-lock extension, but there is downside as well. Downside is this, that still you have only two ISP. So suppose if this link is down, you are there with only one ISP. Is in this case, you don't have redundancy in terms of ISP. You have advantage as well, although you have two ISP, but still you are thinking that you have four different ISP. Means you have four different control connection going towards the controllers, or you have four different IPsec tunnel. This is one of the perfect design. This, or maybe this is the perfect design you have. You have mix of both internet and MPLS. Then you have some internal stack switch. You have the ASA firewall. Actually, this is the design you'll find most of the places people are using. But yeah, different branches, they have different design. This is data center design. I'll come to branch design as well. One, two, three, four, five different design option.
Ratnesh,
Yep.
the last picture, last diagram, so that has connection with crisscross plus it has a T-lock
Discuss.
extension also.
T-lock extension is the extension for control plane. This is some sort of L2 connection here. These switch are transparent switch. Again, it depends upon what type of design we have. Sometimes we are putting redundancy in the switches itself. So whatever switch we have, we are connecting multiple ISP with switch. Okay.
So here in the top picture, there is a T-lock and there is a hybrid type of connection. It is similar like that, means we are using the only one transport site. Means at a time, means at the same time we are using the two transport, but if one is failed, then at a time only one will be active, right?
No, here you have two active transport.
Yes, yes, that is a T-lock, I understood.
Yes, yeah.
This internet in the left-hand side, internet and MPLS, that you are creating the hybrid configuration, right? In the one box, you are going to connect to MPLS and one is going to internet, and in
Yep.
the parallelly there is another box. So it is same like the T-lock, right? Means we have that only the two
Um,
transport here also.
yeah, but this don't have full redundancy, because suppose if this is down, then how many transport you have? Only one, right?
Right, right.
Means this interface is down, but if your this interface is down, still you can go here and here. Okay, means this is like full redundant. This is not 100% redundant. It's something like you're extending your transport. It will give you that capability, but it's not 100%. That I want to tell you. Okay, and now suppose if you have internet and MPLS, for example, you have taken 4 ISP. No one is stopping us to create T-lock here as well. I can go do back-to-back connection and create T-lock extension here as well. So I have
Correct,
four
correct.
control connection per device.
One box, one is MPLS, one is internet, and in T-lock here is also we are going to extend the WAN connectivity from the separate box
Yeah.
in the T-lock.
I mean, suppose if you have only one ISP, then obviously we should go for T-lock extension. Right? We should extend it. Suppose if you have multiple
Yeah,
ISPs, then actually
that
no
is
need.
just for the cost saving purpose.
Yes, yes, yeah, yeah, 100% right.
What you told Ratnesh, multiple ISP?
Yeah, means if you have multiple ISPs, then no need for T-lock extension. But suppose if you have only one ISP, then go for it for T-lock extension.
Even for two ISP also we need, right? It is good. Two ISP. Your scenario, two.
Yes, for two ISP you can go and create it, but it's not required because again T-lock extension itself having some issue, some internal
Issue, eh?
issues. Some internal issues are there with this T-lock extension. If it is required, then configure it in terms of production network. I'm telling you, obviously in lab it will work, but in production, if it is required, then configure it. If it is not required, then if you have multiple ISPs, go for it. Multiple ISPs.
And this
Yeah.
last diagram, what is that L2 switches? What are the benefit we are getting there? I'm not getting that part in the last diagram.
This is moreover, practical type of connectivity. So you are not connecting anything directly with firewall, and then it is going internet. Whenever you have firewall, you can see that firewall is there with some switch like DMG switch, etc., etc. And what you can do here that you can have a stack of switches. So if one of the switch will go down, still you have connectivity with ISP. It's just like high availability and redundancy. That's the diagram here.
Okay.
Maybe it is using the DR circuit, right? Direct internet access. That's why
Yes.
they are going to connect to firewall.
Yeah. Yeah.
Okay, so in one box, one single box, how many transport path we can going to connect? Maximum, is there any limitations?
Limitation is there, right? We have seen that one interface maximum carry 8, right?
8.
Yeah, 8 control connections. That was there when we are creating the template. So
Yes, yes, yes.
limitation is there like 8, 16, 32, like that. Means you can check the data sheet as well for different type of hardware. Different limitations are there that you can check.
Okay, it is depend on the box to box, means what is the
Yes, yeah,
capacity at that box.
yeah, yeah. So initially, you can see that VS devices in our diagram also, you can see VS devices. Now, Cisco is not supporting this VS devices, so they're telling that go for ISR, iOS XE based devices, ISR, whatever Cisco is doing manufacturing. Why? They're telling that they have more hardware capabilities, they can support more and more new features, etc., etc. So in that case, obviously, if it is required, Cisco can increase that capability as well. But 8 is enough. How many ISP circuit one particular device will understand? I think 8 is okay. 8 ISP connection per device. All right. So next thing here you can see this is related to WAN, your transport interface. Then you have this LAN interface. LAN interface is very, very easy to understand. You can go and create L2 VRRP, or you can go and create multi VPN VRRP. Even your LAN interface can pair with some IP protocol as well, or multi VPN IP protocol. Your LAN interface can redirect your traffic towards firewall. We have lab for this, so don't worry about that. We have lab for this, a redirection of the traffic or service insertion lab. So you will understand this. 3 different design actually. This is one type of design. This is other type of design, and this is other type of design for LAN interfaces or for service side VPN.
Can you please explain the second one, this L2 VRRP multi VPN? What is that? You can explain a little bit.
Yes, I will explain. So see, um, this is not a new term actually. Um, we know HSRP, right? HSRP or VRRP,
Yeah.
hot standby routing protocol, etc. So HSRP also, remember when we have switches, and in switch you may have VLAN 10 and VLAN 20. Now for VLAN 10 and VLAN 20, you can go and create VRRP. I'll stick with VRRP. So you can go and create VRRP in a way that for VLAN 10, this is the gateway, and VLAN 20, this is the gateway, right?
Yeah.
Same strategy you can use here as well. Here, instead of VLAN, we have VPN. So I may have VPN 10, I may have VPN 20, right? Now what we can do for VPN 10, this may be the gateway, and VPN 20, this may be the gateway. Like this is primary, secondary, and then again this is primary and this is secondary. So that's multi VPN gateways.
Okay, got it.
Then again you may have peering with any protocol with VPN, or you may have peering with protocol. So VPN 10 I'm using OSPF, VPN 20 I'm using EIGRP, etc., etc. So that's the VPN and plus multi VPN. Okay, great. These are the important design related slides. Then coming back to our template and our lab, I'm going to share you the lab diagram as well, that whatever template we have created, what is our lab. In our lab, we have one data center and we have multiple branches. We have branch 1 and branch 2. I will explain you more about that lab in the next section. According to our lab or according to our network topology, we can go and create the template. So we need to identify, sorry for that, we need to identify that what type of branches we have, what type of data center we have. We need to identify that first, and then according to that, we can go and create the templates. At the moment, we have created one device template with two ISP connection and one management interface. But later on, you have to create template related to service side VPN as well, OSPF, VRRP, etc., etc. Okay, creating template again, it's not a big deal. But point being here is this, that what we want to create, what is our requirement, right? Means OSPF. Okay, inside OSPF, what features we want OSPF? Do we need authentication or MD5 password or plain text password? What's the area ID? It's all these things. Like if we know this thing, when we'll go and create that OSPF, we'll come to know that we have to fill this thing. Yeah, so creating template is very much like if you know the configuration, if you know the concept, then you can go and easily create that template. So in upcoming section, we have to create more and more templates. I'll go and discuss about that. Some of the branch design slides are also there. I will put this particular slide deck. You please go through this particular slide deck. Okay, and next class we can discuss more on this. All right. Great. Any other question you have? Follow-up question, please ask.
Yeah, Ratnesh, I have the one question.
Yep.
So, why we are using the IPsec data tunnel here instead of the BGP? Means if you want to going to communicate to the any DC site from the branch or branch to branch, we are using the full mesh technology, and all the communication is going over the IPsec data tunnel. So instead of the IPsec data tunnels, why we are not using the BGP like the traditional network?
Okay. So why we are using IPsec tunnel means you don't want to use this IPsec tunnel because as I know that different branches, if we do the communication with IPsec tunnel, that data transaction will be secure, right? Means in between, first of all, the concept of SD-WAN is this, that you can use any transport, MPLS or internet, right? And just to do this cost cut, you see that most of the organizations, even big organizations, they have removed MPLS. So they are sending their traffic over broadband, over internet connection. Now, if a big company, big company, they will start sending their traffic over internet without encryption. So it's not safe, right?
But still we are using the MPLS as well in the hybrid environment. Means in the one box we are going to connect the
No,
MPLS.
we are not using MPLS. Means um, not all the companies they are using MPLS at the moment. They are using, so what they are doing, instead of purchasing 100 Mbps MPLS, they are taking 2 gig of internet connection.
Right, right. That is the cost saving purpose. But most of the site we are using the MPLS and internet at the same box. And whatever the critical
Means
application they are
mhm,
sending back to the MPLS traffic.
means you are talking about a specific your
No, no.
company or
Most of the site
organization,
means, any.
because I know few of the companies they are not using MPLS anywhere.
Oh, so they are simply using the internet, right?
Only internet, yes, only internet.
That is the example of the direct internet access, right? DSL.
Yes, yes, yeah.
So maybe, but still in the internet is already secure. That is the IPsec tunnel, right? But why we are using the firewall in that? Because IPsec is already secure.
Yes, so IPsec we are creating here in the boxes. That's why, right?
Mm-hmm. But still we are using a outside external box. We are going to connect to the firewall and then it is going out to the internet. So that is a double security here, right?
Okay, you are telling that we are using ASA firewall. Give me the slide number.
Yes, yes.
Where? In which slide?
The previous in the transport side, you can just check it that, yeah, see here. The box it is going to connect to the internet. Before going to connect to internet, there is a firewall.
Yeah.
So, but data is already encrypted in the IPsec data tunnel. Then why the firewall is needed here?
Your question is really good. Okay, so how you will form the control connection? Because over this transport, you have two different, actually, practically we have three different connection. And the moment just stick with two. One is IPsec tunnel and one is internet. Sorry, one is your DTLS or TLS. So IPsec is okay that you are forming, but what about this DTLS?
Yeah, it is also going towards the internet and going somewhere in the clouds or on-prem devices to communicate with the vSmart to forming the DTLS or TLS connection.
Yeah.
I think Ratnesh, the sites like if, like apart from this SD-WAN or this data infrastructure, internal application data infrastructure, if they want to access the internet directly, so this firewall will come in the picture, right? In that scenario.
Yeah, means the users they want
Yeah,
to
yeah,
access internet so they can
that,
directly go and access it.
that
Yeah.
packet will be filtered by this firewall.
Yeah. So I told you three different tunnels are there. One is for IPsec, one is for control, and one is for this DIA type of connection.
So it will be filtered by the firewall if they are only going to connect to the cloud to access the any specific application.
Any, yes, SaaS type of application. Yeah.
So that traffic will be filtered by this firewall. That's why we are using before that internet, right?
Yeah. As this is one of the strategy. There are other use cases as well, like you are using cloud-based firewall. It's not like physical firewall, but we can use cloud-based firewalls as well. Like you have NetSpoke, or you have what others? Cloud-based firewalls we have. Cisco Umbrella is there. NetSpoke is there. Then you have Zscaler, iBoss, and different vendors are there.
And one more thing, my site here that if the branch is going to communicate to each other over the IPsec data tunnel, they are
Mhm.
simply forming the OSPF, right?
OSPF.
Yes, yes. They are going to communicate. Means, suppose that if you are talking about the MPLS, so in MPLS cloud, multiple router is installed at the network site, right? And our traffic is going towards the multiple router and passing, and then it is going to the hub site, right? So what exactly happening here in the IPsec means once the IP this SD-WAN boxes is forming the IPsec data tunnel, then it is forming the one overlay tunnel over this all the router and going to connect to the this data center devices, VS devices. And once it is going to connect to the data center devices, it is forming the IPsec tunnel. Then we can run the protocol OSPF because this OSPF is running only the point to point, right? If there is a multiple router will going to connect in between, then this OSPF will not configure point to point. So that is the main advantage here. Means if we are going to forming the OSPF connectivity, we want to run the OSPF protocols, that is the ISGP protocols. So we need to two devices would be connect back to back. So this is forming the overlay tunnel. So it will consider like there is the one hub site and there is the one branch site, and in between nothing is there. So I think this is the concept here, but exactly not confirmed. So that's why I was asking.
Okay, for IPsec concept is this, that as long as you have IP reachability, you can form IPsec tunnel. Initially, that IPsec was something that it needs some sort of protocol. Nowadays, I don't think so. It require any protocol to form IPsec tunnel. But if you have IP reachability, then they can negotiate their phases and they can form the IPsec tunnel,
Right.
right? So in between any type of protocol, maybe there is over internet, maybe BGP or anything is there, MPLS, BGP, whatever. But if two ends they know each other, they can ping each other, they can form IPsec tunnel.
Yeah, but if we want to run the IGP protocols like ARP, IGRP, or OSPF, we cannot
Mhm.
configure here because they need their neighbor devices, and that neighbor devices should be directly connected. But if you are talking about the DC and the branch side, there is a
Mhm.
multiple router in between, and we can't form the any IGP protocols. Here, if you have wanted to run the IPsec, then definitely that boxes should be directly connected, and that will be connect through the IPsec data tunnel.
So you are telling that I have two different branch. Again, we are
Mhm.
going ahead of time, but let's see this for 5 minutes and then we'll break. So suppose I have one branch here and I have other branch somewhere,
Mhm.
and they want to run uh, OSPF in between two
Correct,
different branches.
correct, correct.
Okay, why we want to run OSPF in between two different located branch?
Now, suppose that if you are going to connect to the this hub site, that is a DC devices, right? And in between, we are using the MPLS clouds, right?
No, means I'll come to that hub as suppose this is TC.
Mhm.
So I'll tell you one thing very important here, that if you have service side VPN, in service side VPN you are running OSPF or any protocol.
Mhm.
So here also I can run OSPF, but those things, and you will see that how OMP is carrying these attributes, OSPF, BGP, etc.
Correct, correct.
Now this OSPF here is local to DC and this OSPF here is local to branch, but still if you want to exchange prefixes for these OSPF, maybe they are part of VPN 10.
Mhm.
So first of all, they should be redistributed inside OMP reaching
Correct,
to
correct.
VSmart, and then from VSmart it will get exchanged here. That's
Mhm.
the simplification we have in the Cisco SD-WAN for all this complexity related to routing. You have centralized controller where you have all those routing information, and then from here with some policy you can exchange that.
Mhm. But
Okay.
still, we are forming the IPC data tunnel between all the sites, right? Like DC branch everywhere.
Yes, yeah, yeah.
It is a full mesh
So
technology.
it's by default full mesh, but if you want, we can divide it.
Yeah. I think I saw that there is the one command, the show empty peer. So it will show empty peer configuration,
Show
particular specific show empty peer,
MP.
OMP.
OMP peer.
Yeah.
Okay,
So
OMP peer.
so empty peers, and then we are putting the some specific prefix. It will
Hmm.
show that what is the protocol it is running in the IPsec data tunnel. I will
Yes.
show you. I yeah.
Yeah, yeah. That's why I told you that OMP is carrying the attributes of all these protocols. So it will tell you that, okay, it's OSPF internal, external, BGP internal, external, what is, whatever attributes they have in these protocols. OMP is carrying that, and OMP or VSmart has that authority to do the data exchange, either it's a route leaking or same VRF communication, etc. We can check this thing in OMP section when it will come after 3-4 classes. We'll see this thing in OMP. Okay.
Okay.
All right.
Yeah,
Great questions.
Ratnesh, one
Yes.
last thing.
No last thing.
Uh,
Sorry. Bye.